This is part 1 of Chapter 7, Memory. Alright, so for this chapter, we're going to be looking at the different types of memories within Module 7.1. We'll look at the differences and ways that we use to test memory. We'll look at the different type of ways that eyewitness testimony and lineups, when we're talking about criminal justice, how we can minimize those type of errors in terms of speaking about memory, and how actually people who feel they're recalling things accurately really do not. We're also going to be able to distinguish the types of memory, that being short-term, long-term, working, semantic, episodic, declarative, procedural, as well as probabilistic types of memory. Now, anyone who remembers some kind of information and forgets the rest. Think about it like this. Memory is the retention of information. And it includes skills such as like when we're riding a bike or we're tying our shoelaces. It's also going to look at the facts that never changed, like your birthday. Facts that seldom change, like your mailing address. Well, for some people it might go from day to day. God forbid if you're homeless. However, but if it's seldom changing, as well as facts that would frequently change, like where you left your keys the last time you put them down. So you'll remember that your most important experiences, as well as some of your unimportant ones, are going to be many type of useful facts and a lot of trivia that you cannot even imagine that you would use would fall into memory. So when we're talking of memory, we're looking at skills. We're looking at those facts that never change, facts that seldom change, and those that frequently change. We look at our experiences, those that we feel are going to be important and unimportant, and then of course again trivia. Herman Ebbinghaus, he pioneered the experimental study in regards to memory by testing his own ability to memorize as well as retain lists of nonsense type of syllables. What he did was he kind of wrote out 2,300 syllables, assembled them randomly into lists, which is like what you see on the slide, and then he kind of set out to study memory. So what he did was he ran all the tests on himself, and for 6 years, it was a longitudinal type study, he memorized thousands of lists of nonsense type of syllables. And many of his findings were hardly surprising. So one thing was he took longer to memorize longer lists than he did shorter lists. But Ebbinghaus was not just demonstrating the obvious. He kind of was able to measure how much longer it took to memorize the longer list. Measuring how long it takes to learn a list enables psychologists to be able to compare conditions. Do adults learn faster than children do? Do we learn some kind of list faster than other type of lists? These are the type of things that we'll be looking at in terms of memory. So the main methods of testing memory would include recall, free recall, cued recall, recognition, savings, and implicit memory. A simple method for the researcher, though not the person tested, would be to ask for recall. Basically, to recall something is to be able to produce a response. And as you do an essay or do short answer type tests, the free recall method reveals only a relatively strong amount of the memories. Your accuracy would improve with cued recall, and in this case, it's in which you would receive significant hints about the material at hand. When we're talking about recognition, this is when someone chooses the correct item among several options. Now, progressively weaker memories can be demonstrated by cued recall and recognition. Alright, so now we're looking at savings or relearning and implicit memory. In terms of the savings method, this is also considered to be relearning. It detects weak memories by comparing the speed of original learning to the speed of relearning it. So we have the free recall, we have cued recall, recognition, and savings. These are tests that are considered to be explicit or direct type of memory. And pretty much what that means is that someone who states an answer regards it as a product of their memory. In terms of implicit memory or indirect memory, it's an experience influences what you say or do even though you might not be aware of the influence. Now, in terms of talking about procedural memories and probabilistic learning, procedural memories are those memories of how to do something, like walking or eating, if you learned how to eat with a fork or even chopsticks. These are special kind of implicit type memories. Psychologists, we distinguish those procedural memories from declarative memories. And declarative memories are where we can readily state in words. So, for example, if you type, you know the locations of the letters well enough to be able to press the right key at the right time. That's considered to be a procedural memory. But can you state that knowledge explicitly? Like, which letter is directly to the right of C? Or which is going to be directly to the left of P? Procedural memory, or that habit type learning, it differs from the declarative memory in several different ways. First, there's two types of memory, and depending on different brain areas as well as brain damage, if there's brain damage, it can impair one without impairing the other. Secondly, procedural memory or habit learning, it develops gradually. It's not going to be a quick onset. Whereas you often form a declarative type of memory all at once. So think of it like this. You need much practice to be able to develop the procedural memories on being able to play a piano or how to shoot basketball. Habit learning is also well suited for learning something that's usually true or true only under certain circumstances. Like you might notice that certain dogs are unfriendly when they hold their head, ears, and tails in a certain posture. Now, suppose you witness a crime, and now the police want you to be able to identify the guilty person or the perpetrator. You'll look at suspects in the lineup, you'll examine a book of photos. Then it's going to be up to you to be able to use a recognition memory. Are you able to identify the correct person, even if there are some distractions? You know, with a lineup, there tend to be several different people um, to see if you accurately pick the perpetrator. So what happens is this task, it raises a problem. Familiar from your own experiences. So when you take a multiple choice test, another type of way of an example, we're now talking about recognition memory. Sometimes none of the choices are going to look exactly right, but you select the best one available. So what happens if you do the same with a book of photos? What happens if you look through the choices and you pick the one who looks most like the perpetrator? Hmm. If you're wrong, what happens? Your choice, it might not be correct, and a person could wind up going to trial and possibly going to jail based on wrong information. Psychologists have been able to propose ways to help improve suspect lineups. One would be to instruct the witness that the guilty person may or may not be in the lineup. The witness doesn't have to identify anyone. The officer that's in charge of the lineup, they really should be a blind observer. And when I'm saying blind observer, that's someone who doesn't know which person the investigators suspect. Otherwise, what happens is the officer might unintentionally bias the witness by giving hints. If the witness said that the culprit had some type of distinctive feature like a scar above their left eye, or the suspect in the lineup, they really should all present with that feature. Otherwise, the witness would just pick one with a scar, who may or may not even be guilty. They should also postpone as long as possible any kind of feedback about whether the witness chose someone from the police that was suspected. Any type of sign of agreement adds to a witness' confidence, even if the witness was wrong. Instead, what should happen is they should be asking for a definite yes or no decision. They should ask the witness to be able to specify for each person within the lineup, how confident are you that this is the person that committed the crime? The most controversial recommendation would be to present the lineup sequentially. In a sequential lineup, the witness says yes or no to each suspect one at a time. And then if the witness says yes, that procedure is then finished. After all, there is no point in looking at additional subjects if the witness has already said, yeah, that's the person. And the witness has no opportunity to be able to go back and re-examine photos after rejecting them. So in that kind of procedure, the witness will make a definite identification or they won't at all. And rather than choosing the best suspect available. Okay? Now, when we're talking about children being eyewitnesses, research has found that children as young as 3 years old reports an event in which the facts are known with reasonable accuracy, even 6 weeks later than when it happened. There are several factors that influence the accuracy of young children reports. First one will be delay of questioning. After a traumatic experience like an injury, a child's memory is best at first and becomes less accurate over a period of time. Repeating the question. If you ask a child a question and then shortly thereafter ask the same question again, the child often kind of changes the answer. Apparently, a child thinks, well, why is she asking me this again? My first answer must have been wrong. However, if someone else repeats the question, the child will probably give the original answer. Also, it's important to know that it's appropriate for you to be able to ask the question again after a delay, and you might get more information the second time around. The type of question should be using open-ended questions like, tell me what happened. Um, Here, a young child answer is usually going to be short, but it'll be accurate. After a suggestive question such as, did he touch you under your clothing? Children's accuracy is going to be more, well, not more, but less dependable. Hearing other children. When a child hears other children reporting something, is likely to say the same thing, even if it's wrong. Then there's using physical representations. If a child is asked to draw an event as well as describe it, the result is usually going to have a more detailed description with no loss of accuracy. So that's really a good one to use. Then there's understanding a question. Okay, there's a 3-year-old child who doesn't understand a question usually would say what? Yes. So when we're working with children in terms of being eyewitnesses to any kind of traumatic event, it's really careful that we go through these steps and make sure we're not leading children on in any type of way, um, because they are impressionable. They are dealing with conformity as well. So what they might recall or remember can be skewed by how you handle the situation. Now, when we're talking about information processing models, what it does is it helps to compare human memories to that of a computer. Information that will enter a system will be processed, coded, and stored. When you type something on a keyboard, the computer stores it in a temporary memory. When you store something on a hard drive, now you're setting up something more stable and long-lasting. So according to the information processing model, we first take in information and it enters our short-term memory. Think of that short-term memory being a temporary store. And then for some of the short-term memories, it will move and transfer to that hard disk, which is long-term memory. Eventually, we'll be able to take a cue from environmental prompts that allows the system or our brains in this matter to be able to retrieve that stored information. All right, so based on the information processor theory, we know that it distinguishes between short-term memory, temporary storage, and when I say temporary storage, it's temporary storage of recent events, as well as our long-term memory. And with the long-term memory, you could consider it to be relatively permanent, okay? And one way of thinking about it, think about it while you're playing a game. That current score is going to be placed in your short-term memory. And the rules of the game, they're going to be in your long-term memory. You're not going to think about your score the next time you play, more or less. It might still be there and it might not be. But the rules of the game, how you play the game, will actually set and stay in place. Psychologists distinguish two types of long-term memory. It's going to be semantic or episodic. When we're talking about semantic memory, these are memories that's dealing with facts and principles, just like what we're taught in school. In terms of the episodic memory, this is when the memory is going to be towards specific events in your life. So think about it like this. One example can be your memory of the law of gravity. That's going to be considered semantic memory. Whereas you visiting and remembering your grandmother's cooking would be an episodic type memory. Episodic memories are going to be more fragile than semantic memories because when you try to recall an event from long ago, you might be wrong or uncertain about many of the details of that event. People with certain kinds of brain damage, they may lose most of their episodic memories. However, they'll keep the semantic memories. People will also remember a semantic memory, but they can forget the episodic memory or of when or where they kind of learned it. Forgetting when, where, or how you learned something, that is a sign of amnesia. All right, so continuing on about short-term and long-term memory. Psychologists, we've traditionally been able to draw on several distinctions between short-term and long-term memory. One difference is the capacity. Think of it this way. With long-term memory, it's vast. I mean, sometimes it feels infinite. It's hard to be able to actually measure the capacity when we're talking about long-term. Whereas in short-term memory, it has a more limited capacity. Most of us healthy, educated adults, we can kind of repeat a list of 7 letters or numbers or words if we're thinking about chunking, okay? But when we're talking about storage, you can store more information in your short-term memory through chunking or grouping items together in meaningful sequences or clusters. So like if you was to use an example of, let's say, Venty, Ventysy. Here you have 7 letters, and there's a limit for most people's capacity. However, if we said 76, then with those 3 additional letters, they're going to be easily remembered as the number 76. You might change it to the number 76, which would allow you to recall that. 1776 would be even longer, but again, you would break it down to the numbers of 1776, which of course is an important day for U.S. history. But then it allows you to store that single item. Now, Theorists, they've suggested that your immediate attention holds only one item at a time, and any memory for more than one item at a time kind of depends partly on the storage within long-term memory. Other theorists kind of argued about the fact whether or not it's wrong, even to think about a definite capacity for short-term memory. If you look at the array of a few items and then try to remember them shortly afterward, you might or could be approximately right about several of them or exactly right about just one. This is what you can trade capacity for accuracy. So a short-term memory by definition lasts only a short time unless you continue to rehearse it. Why do short-term memories start to fade? Well, the simplest hypothesis or answer to that question would be is that the brain's representation decays over time. Neuroscientists have been able to identify a brain protein that weakens a memory trace. Presumably, it avoids permanently storing unimportant information. Then there's another hypothesis, and that hypothesis suggests that short-term memories fade because we confuse one with the other. So suppose you see or hear a set of 5 letters, and then you count backward by threes for some period of time. On the first trial, you'll probably remember those letters, even with a fairly long delay. But later trials, the task will get more and more difficult, largely because memory of the old items will be interfering with new memories, trying to create new memories. So, how long does a long-term memory last? Well, that really depends. So, if you're playing basketball and you remember the score, approximately how much time left in the game? What defense your team is using? What was the offense? How many fouls do you have committed? And so on. You won't remember this information for the rest of your life, but you also don't need to rehearse it constantly to prevent it from fading. Many long-term memories do last a lifetime. All right, so now let's look at working memory. Originally, psychology, it was thought that short-term memory was the way to store something while your brain moves it into long-term memory. Well, that is, you gradually consolidate your memory. And consolidation basically is converting short-term memory into a long-term memory. It does occur, but not all short-term memories are going to become long-term memories, even after long rehearsal. Today, we've discovered there's been an emphasis in temporary memory storage as the information you are using at that particular moment. It's emphasized that this different perspective, it speaks about the working memory, and this is a system for working with current information. Working memory is almost synonymous with our current sphere of attention, so it includes information you use as well as forget. And it also will include the executive functioning that helps to shift our attention. That hallmark of our good working memory pretty much is going to be that ability to shift attention as needed among different tasks. So the brain is going to pick what it feels that it needs to work toward remembering well, and that it doesn't give high priority to, you might not remember it or recall it. It may not move from working memory into long-term memory. So I'm going to stop here, okay? And we will pick up in either the video or in class.